Okay, welcome class to Unit 4. This is Sensation and Perception. We're starting with an introduction to the sensation notes. Most of the information from these notes can be found in your Myers textbook, page 114 to 124. I would be filling out my packet on page 4 and 5 and be ready to discuss in class tomorrow. So let's start overall. What are the five senses? Hopefully you learned this many years ago, but your five senses are sight, hearing, taste, your ability to touch, and smell. And so now the question begins to come into mind, how does this connect to psychology? Well, it's important to understand how the senses work properly because your senses really impact one's life and your abilities. So let's say, for instance, you didn't have the ability to see. Your life would be incredibly changed by the difficulties that you'd encounter by maybe being blind. Okay, or if you had something wrong with maybe your ability that you couldn't taste and smell, well, your life and the way that you react to things is going to be a lot different than the way that maybe potentially I react to things. So now that you have the senses down, vision, hearing, touch, smell, and taste, you need to know what a receptor is. Okay, a receptor is how a person detects or picks up, okay, a stimulus, which we'll talk about in a moment. So the receptor for vision is eyes. So I've asked the class before, what are your senses? Okay, and students responded with eyes. Well, no, the sense is vision, okay, and a receptor are your eyes. Okay, for hearing, it's your ears. Okay, for touch, it's your skin. Okay, for smell, it is the nose. Okay, and then for taste, it's your taste buds, which are located on the tongue. Okay, a stimulus is the energy pattern that is registered or picked up, detected by the senses. So in order for you to see with vision, the stimulus would be that there needs to be light. In order for you to hear, okay, there needs to be sound waves. In order for you to touch or feel something, there needs to be pressure, okay, hot, cold, whatever it may be, on your skin, okay. Smell and taste, there needs to be some sort of chemical in the environment, whether it's a chemical odor, okay, that your sense, that your receptors, your nose can pick up, okay. So what is sensation? Right? Sensation is the process by which your receptors, your eyes, your ears, the tongue, skin, and taste buds, detect a stimulus, which is the sound, the light, the odors, or the pressure, and creates a pattern of neural messages that represent the stimulus in the brain, giving rise to our initial experiences of the stimulus. So essentially, it's the initial stages of detecting the stimulus and picking it up, okay? And then it's going to be taken to the brain, all right? So sensation is detecting and picking up that stimulus. Transduction, okay, otherwise I think it's known in your notes as transduce, okay? You notice that all of our sensory organs are very much alike, and that's what you'll see, okay? Once the sound waves or the vibrations in the environment enter the ear, the sound waves themselves don't all of a sudden go up to the ear. Okay, it needs to be transferred into like a chemical message. So what transduction is when it changes from a sound wave into a chemical message. So that little message, okay, can take that information to the brain. Okay, the neural impulses or neurons. Okay, so transduction is they all transfer physical stimulus, the light, the sound waves, okay, or maybe the odor even, into neural impulses. Okay, so you have the sound vibrations entering the ear. We'll talk about the auditory canal. Okay, and then it goes all the way to the back of the ear. In the cochlea, which we'll talk about, that looks like that little snail, it changes to a message, and that message then sends the information, whether it's loud or soft or a soothing sound, and that gets processed in the brain. Transduction is interpreting and processing. Okay, so then you have perception here. Okay, so on the bottom it says, kind of understanding perception, do you see faces or do you see a vase? Okay, a lot of students might say both. A lot of students might say the white vase. A lot of students may say the faces. Your understanding of that is perception. How are you perceiving it? So once it goes to the brain, then your brain interprets that message. Okay, so you're seeing light hit the screen or the page. Okay, and how are you understanding that, or how is your brain interpreting it? So perception is a mental process that elaborates and assigns meaning to incoming sensory patterns. It's the process of organizing and interpreting sensory information, and enables us to recognize meaningful objects and events. Okay, perception creates an interpretation of sensation. The second half of this unit, we will look in detail at how our perceptions really work. Okay, the first half of the chapter really understands how the senses work. So we are going to talk about perception. Perception is kind of how your brain organizes it then. Okay, so here's a pretty nice demo of sensation and perception. So you have the stimulus, which is kind of a review. You have the light, the sound, the smell, etc. That's the stimulus in your environment. Okay, and then you have your receptors, which are picking it up, which are your nose, your eyes, okay, your ears. And then it goes to obviously transduction takes place. So now you have your neural impulse. Okay, and then the last stage, it's going to go to the different areas of the brain, okay, and be processed, and that's where perception takes place. Okay, so if you might be a good idea, okay, and maybe you want to draw this image down in your notes, maybe pause it in the process of sensation and perception, and maybe some of those important terms like stimulus, receptors, transduction with the neural impulses. Okay, so here are two terms that you do need to know on how our senses work. We can either come across a new stimulus in our environment and use the bottom-up processing. Okay, this analysis that begins with our sensory receptors touching it, and then our brain interprets it. Okay, so it starts at the bottom of our abilities and it works its way up to the brain. You have no prior knowledge of this information. It's basically just using all of your senses or your sensation. So when you look at a baby for the first time, okay, and they're playing with toys, or they see a toy for the first time, they don't know what it is. A lot of the times they're going to feel it, okay, they're going to touch it, they're going to be using the bottom-up processing in order to really understand what that object is. Okay, so they have no prior knowledge. The top-down processing then is you look at something or you understand something or you perceive it, okay, and then you go and experience it or touch it. So you have already an understanding of what you think it is, and then you kind of uncover it through your senses. So it starts at the brain interpreting it, okay, and then you go explore it. So information processing guided by higher level mental processing as we construct perceptions, drawing on our experiences and expectations. So if I saw a round red piece of fruit on the desk, I would automatically have the perception or the understanding that that's an apple, and then maybe I'd pick it up and be like, oh yes, and this apple's hard and it's round. Okay, that's more you're using your perception to understand your environment. So both of them help to understand the environment. Again, top down, you're starting at the top of your head. Okay, the top, you're using your brain to understand what it is. Okay, what if we could sense everything in our environment? Obviously, our senses would explode. Okay, or we would be taking in too much information or having too many perceptions, or we'd have way too much stimuli. Okay, so the people who study the sensation is called psychophysicists. Right, so there's another career in psychology. You want to know what it's like to have the ability to see and hear and understand how our senses work together. Okay, this is a field maybe you'd be interested in. This is the study of psychophysicists. It studies the relationship between your physical stimuli and our psychological experiences in them. Okay, it studies sensation and perception. So we will look at a case where victims who lose their limbs or lose their legs, they call what's known as the phantom limb phenomenon, where they feel in their brain, they're still interpreting in their brain, since there's sensory neurons that are still responsible for sending information to the toes, since they're still there in your peripheral nervous system, there's still the messages going up to the brain that their toes itch. And so it's if they really still feel their toes, which is kind of crazy. Okay. So they would be studying how all that information kind of works and the understandings of it. Okay. Okay, so then you have the absolute threshold. Okay. Absolute threshold is the minimum stimulation needed to detect a stimulation 50% of the time. Okay, so what this essentially is it's the smallest amount of stimulus that needs to be in your environment in order for your receptors to detect it. So it's the smallest quantity of physical energy that can be reliably detected by an observer. Okay, so if you had a really, really, really low threshold or a low sound, okay, and let's say it was like a ringtone, and it wasn't within my ability to detect it, okay, it's not reaching that absolute threshold. And everybody has a different absolute threshold, okay? My absolute threshold is probably not as low as yours because you could detect sound better probably than me, okay? So here's a very small image. Maybe you can't make out what it is. The threshold's too small, okay? And then as it gets larger and larger and larger, you're able to understand or detect what it is. Okay. Here's an example of absolute thresholds that they've tested. So they've tested the furthest distance away for people to actually still be able to see a candle would be 30 miles. Now, if you went 31 miles away, okay, an average person might not be able to detect it. Okay, hearing, they say you can hear a ticking of a watch at 20 feet. Okay, tasting, they say if you put 1 teaspoon of sugar and 2 gallons of water, you'd still be able to detect that taste, that it's not clean or it's not just pure water. All right, but let's say that they only put a half a teaspoon in 2 gallons of water, you wouldn't be able to detect that sugar. Okay, the smell, 1 drop of perfume throughout a 3-room apartment, probably with not a lot of other people in the environment, and then the touch of a bee's wing on your cheek. That is the smallest, like maybe little brush or little feeling or pressure on the skin that one can detect. Because you can't detect, like when I have 1 strand of hair, maybe on my back, okay, I probably can't detect it. But if I had 2 or 3 and it was kind of, going back and forth on my back, I would be able to feel that, or in front of my face. Okay, so signal detection theory, what really impacts our absolute thresholds or our senses, okay, and whether or not we're going to respond to it is the sensitivity, the strength of the stimulus, okay. Our response criterion, we detect stuff based on our experience, okay, our motivation, okay. I might be willing to hear something more particularly if I know it's coming or I'm waiting for it. Fatigue could also impact it. All right, I might not notice something, a stimulus in my environment, if it's really quiet or if I'm really tired. Okay, and assumes that we do not have an absolute threshold because people are paying attention to the physical sense and they're always changing. So this one maybe isn't looking at that we have absolute thresholds in terms of the signal detection theory. Subliminal stimulation is information that's below our absolute threshold. Okay, so it's below one's absolute threshold, okay, but it's still part of our conscious awareness. Okay, does this work? So back in the 1940s and 1950s, they said that they used to sneak in images of popcorn, like every 1/10 of a second in the movie screen. And since it wasn't playing long enough for people to be able to detect it, okay, people wouldn't necessarily be aware of it. But they said, since it's still in their field of vision and their brain is still detecting it, that it's still, even though people weren't really thinking of it, it still became part of their awareness, and then popcorn sales went up. Okay, so the argument of this kind of mystery or this study was done, like I said, in the 1950s. Okay, studies show that some emotional reactivity, this is called priming, setting somebody up, okay, for a particular response. Laws were passed to restrict this marketing. In some cases, they can't do this in society today. So if you're watching a commercial, they can't, let's say you're watching a commercial about drinking Pepsi or Coke, okay, they can't start putting information in that message that would lure you to buy it that's below your threshold. Difference threshold, we'll look at the word difference threshold. So you can tell the difference between two stimuli. The smallest difference in the stimulation that can be detected by an observer when there's two stimuli are compared. It's also known sometimes as the just noticeable difference. I always give the example of I can't tell the difference between a regular TV set and an HD TV set. There's not a big enough difference for me to understand, okay, or for me to see the difference. However, I can notice there's a difference between Diet Coke and Diet Pepsi. Okay, I can tell that if you gave that to me, I can know that there is a difference between the two. Okay, Ernest Heinrich Weber came up with Weber's law. Okay, the law was originally used to describe the research on weightlifting. They wanted to know how much weight needs to be present in order for you to notice that there's a difference in the weight. Okay, you noticing the difference between a 50-pound weight and a 51-pound weight, you might not notice the difference. However, if you went from a 50-pound weight to a 100-pound weight, it's proportionately different, so you notice that there's a difference in the stimulus. Okay, the idea that to perceive a difference between two stimuli, there must be difference by a constant percentage, not a constant amount. Okay, so there needs to be a constant percentage for that item versus looking at the amount. Okay, not a set weight. Okay, it needs to be a proportion. So you can't, obviously you'd be able to tell the difference, okay, between maybe a 6-pound and maybe a 7-pound if you add one more pound on. But if you went from 50 to 51, if you had one more pound on, you wouldn't be able to tell the difference. So you need to add a proportion, okay, to that weight versus maybe a number to the weight. Okay, and there you got our weightlifters there. Selective attention. Selective attention is at any moment we focus our awareness only on a limited amount of aspects of all that we are capable of experiencing. Even though you think that you can multitask and do a lot of things at once, studies show that we have a selective attention and you could only be doing one task at a time to do it well. There's other things in your environment, like you listening to me and taking notes, okay? You can't have the TV playing in the background, okay, because something is going to be blinded, and the intentional blindness hopefully would be the TV set, your failure to notice that other things are going on in your environment. Okay, my example I always give for this one is when I'm driving to work. Okay, a lot of the times I'm so focused on the car in front of me, okay, or my selective attention is driving in front and just following all the rules, that I was intentionally blind to an accident that was occurring on the other side of the street. Okay, because my intentional blindness would be that accident. Change blindness is a phenomenon that occurs when a person viewing a scene apparently fails to detect a large portion of the scene even changes, and we'll see an image of this in class. But you're so focused on maybe getting a set of directions from one person, and you're so focused on writing down those directions that the person or the background changes, and you don't even notice it because you're so focused on the person. That's called change blindness. Okay, sensory adaptation, well, your senses adapt. Okay, so adaptation, the reduction or disappearance of a sensory responsiveness when the stimulus is unchanging or repetitive. Okay, so your senses are now becoming adapted. So I always use the example of when it's cold in the classroom. Okay, you first walk into the classroom and it's freezing cold, and you're so cold and you're so cold. And over time, maybe halfway through the class, your body becomes so adapted to it that you don't even realize it's cold anymore. Diminish of the sensitivity as a result of a constant stimulation. Okay? So kind of wrapping up, all right, you understand the process of the difference between sensation and perception. There was a lot of terms that we went over in the beginning that you should know. You should know the difference between a receptor and the stimulus and transduction. You should know the difference between bottom-up and top-down processing, difference between absolute and difference threshold. Okay, you should understand what selective attention is, intentional blindness, and change blindness, and last but not least, sensory adaptation.